Hi again guys, welcome to the second part of our tutorial on differentiation using first principles. And in this tutorial, after looking at the theory of where the formula comes from, I want to now look at using the formula to differentiate functions using first principles. We're going to look at two different examples of how to use the formula and how we come up with the gradient function or the derivative using first principles. Let's consider this first example here, where we're asked to find the derivative of x squared minus 2x. Now, we know that if we used the differentiation rule that we were working on a couple of lessons ago, we would know that my derivative here would be equal to simply 2x minus 2. Now that's the differentiation rule, very quick, very simple. But if I was asked to find this derivative using first principles, I would have to approach it in a totally different way. I would have to use our formula that we derived in the previous tutorial. So to do this, what I would need to do is write the formula down first. F dash x is equal to f of x plus h minus f of x over h. And this is when the limit of h as it tends to 0. So what I'm going to do now is I'm going to sub x plus h into this function so that it will become x plus h squared minus 2 times x plus h. And then I'm going to subtract from that f of x. And f of x is the original function, x squared minus 2x. So that I'm subtracting x squared, and I'm subtracting negative 2x, so it becomes plus 2x. And the whole thing is over h. Now you'll find when you look at the numerator now, I have to expand some brackets. So this bracket here will become x squared plus 2xh plus h squared. The second bracket will become minus 2x and minus 2h. And then I've got minus x squared again plus 2x. And the whole thing is over h. Now if you look at the numerator, you'll see certain terms which will cancel each other out. I have x squared minus x squared. I have negative 2x plus 2x. And what I'm left with is 2xh plus h squared and minus 2h. And then the whole thing is over h. Now, we know now that I can't yet let h equal 0. If I did, this denominator would become 0 and the whole equation would become undefined. So what I need to do is I need to simplify again. I have to take h out as a common factor in the numerator so that I'm left with 2x plus h minus 2. The whole thing over h. And this means that I can cancel my h's out. And that means that I'm finally left with 2x plus h minus 2. Now I can let h equal 0, as I would with any limit, as we saw in the previous two exercises. When I let h equal 0, f dash x becomes 2x plus 0 minus 2, which means that f of x will be equal to 2x minus 2. And hey presto, we're left with this answer that we've got up here that we found in 2 seconds. An awful lot of work, I know, for the same answer, but it's this method here, using this formula, which is differentiation using first principles. Let's have a look at this example now. Similar, we have this function here, 2x squared plus 5x minus 2, and I'm going to differentiate this using first principles. Okay, I'm going to find g dash x, which we know is the derivative function. Now again, if I was using the quick rule, the differentiation rule, I know that the final answer I should get for this is going to be 2 2's are 4, so it'll become 4x plus 5. Now I know before I even start that this is the final answer I should end up with, but I'm going to differentiate using first principles here, so I need to use our formula. So using the formula, remember f dash x is equal to the limit as h approaches 0. Oops, go back. The limit as h approaches 0 of f of x plus h minus f of x over h. Now, let's sub x plus h into this function here. So I'll end up with 2 times x plus h squared plus 5 times f of x, 5 times x plus h minus 2. And then I'm going to minus the original function. So I will minus 2x squared, I will minus 5x, and I will minus negative 2, which becomes plus 2. And the whole thing is over h. Now I have to expand all my brackets. So I will end up with 2 times x squared plus 2xh plus h squared plus 5x plus 5h minus 2, and then I've got minus 2x squared minus 5x plus 2, and the whole thing is still over h. Now I've finally got to expand this first bracket, because this will become 2x squared plus 4xh plus 2h squared, and then the rest of it plus 5x plus 5h, okay, minus 2 minus 2x squared minus 5x plus 2, and the whole thing is over h. Now let's cancel out what we can cancel. We have positive 2x squared minus 2x squared. We have positive 5x minus 5x. We have minus 2 plus 2. And what I'm left with here is 4xh plus 2h squared, and then plus 5h. And the whole thing is over h. Now again, I have to simplify the numerator. I have to take h out as a common factor, and I'm left with 4x plus 2h plus 5. The whole thing over h. H's cancel out, and I'm left with the final expression of 4x plus 2h plus 5. Now remember, this is the gradient of the secant. I have to now let h equal 0, because I have to find the limit as h tends to 0. So if I let h equal 0 now, f dash x will become 4x plus 2 times 0 plus 5. This will simplify to 4x plus 0 plus 5, and my final answer will be 4x plus 5. And once again, here I am back to my original answer over here, which I knew I should get from this process. But as you can see, the process is not using the differentiation rule, it's using first principles. And this is the process you must use if the question asks you to differentiate using first principles. Very important. It's a lot of work. We don't do it very often, but certainly for our course in Year 11, there are questions which will ask you to do this. Next lesson we will go back to looking at differentiation using the much quicker differentiation rule, this one up here, which you'll be very glad to know. But you do need to be working on differentiation from first principles. Now, in exercise 9C, these are the questions that I'd like you to work on. Questions 1 to 5, question 6 and question 7. I hope this has made differentiation from first principles much easier for you to follow and understand, and will make doing this exercise easier. Please look over the tutorial again if you're not sure about anything. Have fun everyone. Hope you found it useful.